In this video, we're going to practice dividing exponents with the same base. Now, what is the formula for dividing exponents with the same base? The formula is base x raised to the m power divided by x raised to the n power. We keep the base because they are the same, and we will subtract the exponents. Now let's look at our first practice problem. We have x to the 8th power divided by x to the 3rd power. So we will keep the base and we will subtract 8 minus 3. Now 8 minus 3 will be x to the 5th power. Now how did we get x to the 5th power? Although we subtracted 8 minus 3, which we know it will give us 5. But let's prove this. Let's show this in a more clear way. So on the numerator, we will have 8x, and on the denominator, we will have 3x. And because we have the same variables, let's cross them out. We need to cross 3 from both numerator and denominator, and on the denominator, we basically stay with 1. And the exponents are raised to the first power. This is something that you should know. The exponents are not raised to the 0th power. That is why we get x to the 5th power. Let's look at problem number 2. We have 5 raised to the 7th power divided by 5 raised to the 3rd power. Well, this is the same as 5 to the 7th power divided by 5 to the 3rd power of 5 cubed. Now, because we have the same base, we need to subtract the exponents. 7 minus 3. If you subtract 7 minus 3, you will get 5 raised to the 4th power. And before we find the final answer, let's prove this, and let's also prove and make it clear to understand why we got 5 to the 4th power. So on the numerator, if you see 5 is raised to the 7th power, so it means that we should have 7 5s in the numerator, and on the denominator we have 5 cubed, so we are multiplying 5 3 times by itself. And now let's cross out 1, 2, and 3. So you see on the denominator, we basically stay with 1, and the 5s are raised to the first power, to the power of 1. And that is why we get 5 to the 4th. But now, what is 5 to the 4th power? Let's try and find the final answer after expanding 5 to the 4th power. So we are basically multiplying 5 4 times by itself, and we can multiply 5 times 5, that will be 25. 5 times 5, that will be 25. Now let's multiply 25 by 25 and let's find our final answer. So 5 times 5, that is 25. 5 times 2, that's 10 plus 2, that will be 12. Now we have a 0. 2 times 5, that will be 10, and 2 times 2 is 4, plus 1, that is 5. Our next step is to add. Let's bring down the 5, let's bring down the 2, and 5 plus 1 is 6. So our final answer is 625. Now let's move on to problem number 3. We have 3 raised to the 4th power and we have 3 raised to the 6th power. So we have the same base, and now let's subtract 4 minus 6. Now 4 minus 6, we will have a negative answer as our final answer. We will have 3 to the negative 2 power. But why is that negative? So let's prove this again by expanding the numerator and the denominator. Let's multiply 3 4 times, and on the denominator we will have 3 times 3 times 3 times 3 times 3, multiplying it 6 times. Now let's cross out 3 3 3 until we run out of 3. So on the numerator we simply have a 1, and on the denominator we will have 1 over 3 to the 2nd power. So now you see the difference. So our final answer, what is the final answer? So what we do next, if we want to find the final answer, we need to expand 3 to the second power. So 3 to the second power will be 3 times 3. And 3 times 3 will be 9. So our final answer is 1 over 9. Now, let's talk about 3 to the negative 2. If we wanted to just quickly go and turn the negative 2 to a positive, we simply put 1, we put it over 1 if we want to have that negative exponent to be positive. So that's our final answer.